Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at another calculator version 2. This video is part of a series of videos that falls under the fundamentals demo, and it also assumes that you've taken a look at the calculator version 1. Once again, we're going to be taking sort of a top-down approach to our design, including some helper functions that I have in your calculator version 2 snips file that are the same as the ones for the version 1, particularly the add double, subtract double, multiply double, and the divide double. And in addition, I have an additional helper function called help calculator that just simply is a convenience function that allows for us to display the help at multiple points through our code without having to have redundant printf statements. So to begin with, what we want to do is we want to grab a copy of the calculator version 2, or you can simply take a screen capture of it. And then what we want to do now is we want to go ahead and copy our function prototypes over to our list of function prototypes. If you've already done the helper functions, the only thing you should need to copy over are going to be your calculator version 2 and our little helper function. We do want to go ahead and copy over the code for the main driver of this example, as well as for the help that we are going to use. Make sure to go ahead and copy the comments as well. And optionally, you may choose to go ahead and move this up a little higher in your fundamentals demo so that you can take a look at both the calculator version 1 and the calculator version 2 next to each other. All right, before we go on, let me show you how to split screen, and that means you can drag down the horizontal bar. And at this point, what I'd like to do is I'd like for us to just briefly take a look at the difference between the two options in these two examples. So you'll notice that in the version 2 of our calculator, we have the ability to call help explicitly as well as exit our calculator. And additionally, what you'll notice is that we are going to employ the reverse Polish notation for our version 2. I provided you a link for that. But in summary, what happens here is that essentially we are provided the values first, followed by the operands. So we're going to do this a little bit differently than version 1. So let's go ahead and get started. The first thing you'll note here is that I have provided some of the printfs already for you, just once again to make this a little simpler so we can focus on the algorithm, not necessarily on the help. And then much like in the first example, we want to be able to capture some of the values that the user inputs. And so at the very least, we're going to need a few temporary variables here, much like the first one. So it's going to be our double first, our double second, which will be the two values that will be captured by our program from the user. We may use this results variable. I'm going to put a little comment here. May not be needed. You'll see why in a little bit. We also want to go ahead and capture the option. And the option should be an integer, as well as a flag for whether or not the option, or perhaps the second number in the case of the division, is in fact valid. And then we're going to need a couple of additional flags in this particular function to make this one work. The first one is going to indicate whether it's the first time we run this function. So the reason why we need this is because the behavior is going to change after the first run. And let me give you an example here. So in the first run, we're going to prompt the user for 2 values. In subsequent runs, once the results are calculated from the first run, the results from the first run or the results from the previous run become the first value. So make a little note to yourself here is that the results from subsequent runs become the first value. So in other words, we're going to have different behavior depending on how many times this loop is run or how many times this function runs its loop. And then the last one that we want to do is we want to have a flag then that simply controls whether or not the user is done using our application. And so in this case, what we want to do is we just simply want to create one more flag called done. And so this allows the user to gracefully exit our application instead of having to hit Control-C. Well, let's go ahead and get started here. You'll see that we provide some basic information to the user. Welcome to Calculator version 2. Tells us a little bit about what this is going to do. You can definitely elaborate on this a bit. But the first thing we want to do is we want to start initializing some of our values here. And so we're going to not worry about the first and second nor the results because those are going to be handled via the scanf. But we want to go ahead and initialize, for instance, our valid. And we said that we're going to assume that valid is going to be false, at least initially. We are also going to initialize our first run equal to true. And then we also want to initialize done. In this case, we want to think a little bit about the logic here. In other words, if the user is done, we want to exit out of the loop that ultimately controls this function. So essentially what we want to do here is we want to assume that the user is not done, or rather that done is simply going to be equal to false. So the user is not done until they specifically select exit. And that's how we're going to ultimately drive this calculator. So to begin with here, our outer loop is going to simply check to see whether done is equal to 0, and while it's equal to 0, it's going to continue attempting to collect information from the user, including the values and the option, which leads us then to the first decision that we have to make. Is this the first run? So if first run is equal to true, remember we said that we're actually going to have to capture two values. So let's make a quick note to ourselves here. So capture two values, else if first run is equal to false, we capture only the second and reuse the results from the previous run. This gets into why we technically won't really need that results temporary variable, and you'll see that in just a second. Well, to capture the two values, it's pretty straightforward. We're simply going to have a nice message to the user. Please enter the first value, followed by a new line, and then a scanf that simply allows for the user to enter in the value and store it at the location of first. We do the same thing now. Sorry, I had a print instead of a printf there. We do the same thing now for the second value. So please enter the second value and follow this one up with a scanf, once again with a %lf and a ampersand second. All right, now let's think about what this else will look like. And we said here that the else only captures the second value and reuses the results from the previous run. So in this case, then essentially the only thing we're going to have here is going to be a printf, please enter the second value, and a scanf with a %lf ampersand second. Now, note here that we are doing no validation of the data because, number one, we don't know which option the user is going to select. We're going to ask that question next. So in order to be able to ask that question, then we will have had to have given the user the instructions. And so at this point, then you've got a couple of options how you want to give the user the instructions. You could give them the instructions every time the outer while loop runs, which might get a little annoying, or you could simply give it to them once prior to running the while loop, and then only when they either make a mistake or explicitly ask for help. This is one of the reasons why we like to have this little helper function that gives the help explicitly for the calculator, because then we don't have to worry about rewriting that code in multiple locations. And so in this case, it's just simply a call to our help for our calculator. And we can do this once outside of the while loop. And then after collecting the first two values, to keep consistent with our reverse Polish notation, we will now print a prompt to ask the user to select which option they would like. So in this case, what we're going to do is we're going to follow this up with a printf. Please select an option 1 through 4, or 9 for help, or 0 to exit. Now, the question becomes, how many times do we want to prompt the user to select an option? In other words, if they erroneously put in an option, we would like to re-prompt them again. So this means we're going to wind up with another while loop. So in this case, we're going to have a nested while loop. And in this case, what we're going to do is we're going to use our valid flag to drive this particular while loop. So think of it this way, that we're going to continue prompting the user for the option while they are unsuccessful at entering in what they want to do. So in this case, what we'll have here is while valid is equal to false, we simply move our print statement inside of there, and we follow it up with our scanf. In this case, it's going to be for an integer, and we store it at the address of the variable option. Now, at this point, we can jump into triaging our option. Now, this is not going to be terribly different from the previous calculator. We just have a couple of additional options to handle, specifically the help and the exit. So let's go ahead and get started here. We're going to go ahead and set up here with an if statement. We're going to explicitly check to see if option is equal to 1, in which case this is the addition. Else if option equal to 2, this was the subtraction. Else if option equal to 3, multiplication. Else if option equal to 4, that's the division. Note, more error checking needed. And now the additional options, else if option equal to 9, and else if option equal to 0. And then lastly, an else. So if our option is equal to 9, we want to call help. And if our option is equal to 0, we want to allow the user to exit. And then under the else, we also want to call help, because basically it means that the user did not put in an option that we expected. Now you'll note here that very quickly, I have essentially documented what we want to do before writing any real code. So this is a good habit for you to get into, as well as I'm going to take just a second to clean up my code. You don't necessarily have to have the spaces there. It just increases the readability a little bit. But let's say you had to stop at this point. A coworker of yours could easily pick up with the code that you have written and complete our function. So let's get back to it. What do we want to have happen if our option is equal to 1? Well, in this case, we can do exactly like we did before. We'll leverage our results variable, and we'll simply specify our add double by passing the first and the second value to it. And at this point, then, it will simply calculate the results. In other words, add the two values together and return it to the results variable. Likewise, what you can do is you can also go ahead and print out the output of this operation. So we could have something like printf, and the %lf, rather, the %.4f, we're going to go to 4 decimal places, plus %.4f is equal to %.4f, followed by a new line, and then we simply specify the first, the second, and then the results. Now, if you recall earlier in the video, I mentioned that we're going to be using the results of our calculation as the next first value. So in this case, once we have been successful at our operation, in other words, that we've reached a valid option and we have calculated, you can simply say first is equal to results. Now, what I'd like to do is I'd like to take just a second to show you an alternate way of going about doing this. I'm not necessarily going to encourage this, but I do want you to be aware that you can essentially do this twice, essentially make 2 function calls. And at this point, what you would do here is you would simply say printf %.4f plus %.4f is equal to %.4f. And then for the first placeholder, simply first, second, and then make a direct call to add double. In this case, it's going to be the first and the second values that are passed. The problem with this approach is that it does not capture the results. It simply prints them to the console. So you got to sort of factor in how you want to go about doing this. So in this case, though, since we do still want to go ahead and print out this statement here, if we did not want to do that, we want to capture the results. So we're only making one call to our add double. If we chose not to print out the results, in other words, if we didn't want this nice fancy output, then let's make a quick note here, if no output needed, or that you simply wanted to print the output of the function, you could do something like this right here. You would say first is equal to add double first, comma, second, but then essentially what you would do is you would lose the previous first value. So in other words, you would only be able to print out the %lf, followed by the new line, of course. And in this case, what you would do is you would print out the first, which would act as the results. So I'm going to leave this for you to decide which way you would like for your calculator to work. For the remainder of this video, what we're going to do is we're going to do this multi-step approach because I believe that it's a little clearer when we get started. And that is we're simply using our temporary variable, results variable, to capture the results for our operation, make a nice printf as a fancy output, and then simply assign the results to the first value for the next iteration of our loop. At this point, you should probably recognize the pattern. In this case, results is just simply going to be subtract the first and second. And once again, a printf, %.4f minus %.4f is equal to %.4f, followed by a new line, first, second, and results. And with that third step simply being that you assign the results to the first variable. At this point, we just simply repeat for the multiplication. And then we come back to our division. In the division example, we said that we need to assure that the second value is, in fact, not equal to 0, in which case we're going to set up a third while loop. In this case, what we're going to do is we're going to look at the second value. And so while second is equal to 0, we simply want to prompt the user to enter in another value. And we can do this as an error or as a warning or as a note. So warning, please enter a non-zero second value. Followed, of course, by a new line and a scanf. So in this case, it's going to be scanf %lf and the address of our second variable. Once we have successfully escaped out of this while loop, in other words, that either the user correctly entered in the second value to begin with and the while loop never ran, or we've succeeded in convincing the user to enter in a non-zero second value, at this point, then we can simply say results are equal to divide double, first comma second, and just as before, we can just go borrow the print statement and change the operator, and then go ahead and assign first equal to results. Rather, I should say assign the results equal to the first variable. Now, what happens if we hit option equal to 9? Well, in this case, all we want to do is we want to make a call to our help calculator, as we would also want to do if we hit the else. So in this case, then simply type in help calculator. And then what do we want to do when the user really wants to stop using our application? In other words, they've specifically said, I want to exit. In this case, what we want to do is we want to set the done flag to true. The user is done. In other words, they don't want to have anything more to do with our application. Well, this brings us to our while loop that we have that is controlled by the valid variable. And if you'll note here, so far we have written an infinite while loop. how do I know this without running it? Well, because I don't actually change the value of valid anywhere inside of the while loop. In other words, we've got a problem. So let's think about, what does it mean to be valid? Well, in this context, valid means that the user selected an option that was on our list. In other words, 1 through 4, 9, or 0. And it's just simply that straightforward. For every option that we wanted them to select, we simply say valid is equal to true. All right, and then so down here, valid equal to true, valid equal to true, and then valid equal to true. Now, let's think a little bit about what happens with option 9. Option 9 means that they wanted to see the help. That doesn't mean that they were ready to exit necessarily, but they just didn't know which integer corresponded to which operation. So from this perspective, you have to ask yourself, is valid in fact equal to true? In other words, are they done with the while loop? Or do you simply want them to see the help followed by re-prompting them for the option? So in this particular case, what we're going to do is whenever we call help, we're essentially going to say valid equal to false. Now, the value of valid is already false, so essentially all I'm doing here is reinforcing the value. But basically, this means that it's going to run the while loop one more time after seeing the help. Same is true for when they implicitly call for help, meaning that they didn't select an option that was on our list. So you don't have to actually type this code in, because since no change is made to valid, then that value does not change. That brings us now to option equal to 0. In other words, did they select a valid option? The answer is yes. They did, however, also want to leave the application period. So in this case, what we want to do is set valid equal to true. And then you'll note here that when we come back out to our outer while loop, it's not only going to escape from the inner while loop, but also from the outer while loop. Now, this application can in fact be written with breaks, but as I've mentioned in an earlier video, it's better for you to explicitly state when you want to leave the while loop and have that controlled by the while condition, instead of simply having multiple breaks inside of your code. This right here results in some very clean, very readable code that accomplishes the same thing that a premature break would do. So at this point, we can go ahead and build it. Let's see here. We appear to have a typo here. I got a little carried away with my equal signs. Sorry, sometimes these errors, I just have to laugh at some of my own errors. I encourage you to get to that point as well. Don't let this be a frustration for you. All right, so it looks like our code runs, or at least build. And now what we want to do is we want to come up here to our main. Let's go ahead and collapse some of these here so we don't have to travel quite as far. And then you can come up here to your help, and what we'll do is we'll go ahead and add a little bit extra in our help. We change calculator version 1 to calculator version 2, and then we can also expand on our else if to include our calculator version 2. And at this point, we should be set to go. So let's go ahead and build it. Let's go ahead and come out here to our command line. let's go find our projects, in this case, our fundamentals demo. We'll look for our distribution folder, debug min-gw. There's our fundamentals demo once again. And now what we want to do is we want to run our calculator version 2 switch. And you'll see that we provide a nice little bit of help or instructions to the user, as well as an introduction to the user. We have our table here. We're asking to enter in the first value here. We'll keep this test simple. So 1, 2, and then I'm going to add these two values together. You'll see that it is value equal to 3. And you'll notice that right off the bat, I'm being prompted now to enter the first value in. Well, we said as we were going through this the first time that we wanted to be able to reuse that results variable as the first value after the first pass. So if you go back now to our function, and specifically if you take a look at our triaging here, in other words, if first run is equal to 1 or true, what we forgot to do is we forgot to set this flag equal to false after successfully capturing the first two values. So what I'm going to do now is I'm going to go ahead and escape out of my executable. I'm going to come back here into my code, and I'm simply going to set first run equal to 0. So note here, after the first run, set this flag to false. All right, so once again, let's build it. Let's come back out here. Let's test this once again. Enter the first value in. Enter the second value. Choose the option. And you'll note that now I am being prompted to enter the second value only. So I'm going to test this now. I'm going to put in 1 again. And now I'm being prompted again to enter the second value. So still we seem to have something wrong with our logic here. So let's come back one more time to our code. Let's make sure and escape out of our console real quick using Control-C. And then let's come back to our code and let's see if we can figure out what's going on. So if you'll notice here, we have initialized our valid equal to false outside of an outer while loop, so that the first time through, we are correctly controlling this inner while loop. But remember that with a while loop, you must always initialize your flag such that the while loop would preferably run at least once, if that's your intention. In this case, it is our intention. So put another way, you'll notice that essentially valid is equal to false when we run it the first time, but once we have successfully entered in a valid option, we switch valid to equal true. To compensate for this, what we want to do is outside of our middle while loop, we simply reinforce the value of valid equal to false. And note that this is the first time that we use valid inside of the outer while loop. And such that every time we start off this while loop, valid will be equal to false, which means this while loop is guaranteed to run at least once. All right, so let's go ahead and give this a shot real quick. Let's go ahead and build it. We'll go ahead and run this one more time. We'll select 1.0 for the first value. We'll put in 2 for the second value. We'll choose addition. Notice I'm now being prompted for the second value. I'm going to add 1 again. Now I'm being correctly prompted for the option. Okay, you'll see that by setting valid equal to false at the beginning of your while loop, specifically setting valid equal to false before you run that middle while loop, will assure that that while loop runs at least once to prompt the user to select an option. So in this case, I'm going to select option 1 one more time. And you'll notice now that I have 3 plus 1 equals to 4. Well, where did I get the 3 from? Well, I got the 3 from the previous iteration of our while loop. In other words, from the previous calculation. I'm being prompted to enter the second value. And again, I'm going to put in 2 this time. This time, I'm going to use option 2. So subtraction. So I should get 4 minus 2. I'm going to enter in 3 now for the second value. I'm going to test my multiplication. So 2 times 3 is 6. I'm going to enter in the second value. In this case, I'm going to put in 0. Please enter an option 4. I get the warning. Please enter a non-zero second value. And you'll notice here, though, that I need to put a value in to satisfy this while loop. So now I'm in my innermost while loop. So I'm going to do it one more time incorrectly. You'll see that I'm going to get prompted again. At this point, you probably could consider putting a count here so that the user is just continually trying to crash your program. You provide more severe warnings. In this case, I'm just going to change my value. And you'll see 6 divided by 1 is in fact 6. And then now I'm going to go ahead and enter in one last value here. I'll put in 0. And then I'm going to test my help by selecting 9. You see that I get my options once more, but once again, I'm being prompted for which option I want to do. And then finally, I just say, forget it. I'm done using your executable. And I type in 0 and I gracefully exit. So hopefully you found this example very enlightening, including some of the intentional mistakes that I made here so that we would have to go back and see where to improve our code. I also hope that you appreciate now these flags here, or these integer variables that essentially act as Boolean values. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.